We all feel the relentless march of the clock, but are we truly trapped in the present moment, or is there a way to move freely backward and forward? For most of human history, we've treated time like a rigid, universal metronome. We view it as a one-way street, pushing us steadily into the future, second by second, with absolutely no way to hit reverse. Albert Einstein proved that time is not an absolute measurement. Instead, it is inextricably woven together with three-dimensional space, creating a single, flexible, four-dimensional fabric known as space-time. Einstein proposed that stars and planets physically reshape the void around them. Their immense mass forces the space-time grid to sag and stretch, creating the curves we perceive as gravity. Because time is physically bound up in that grid, it isn't a strict universal rule. It is a dimension, and like any physical dimension, it can be stretched, distorted, and manipulated. If you take a ship and park it near a supermassive object, like a black hole, the gravitational pull is so intense that the structure of space and time is stretched to its extreme limit. For you inside that ship, the flow of time physically slows down compared to the rest of the universe. The math tells us exactly what happens next. You could sit near that black hole for a single hour, check your watch, and return home to find that entire decades have passed on Earth. Physicists call this specific effect gravitational time dilation. This is an active feature of our universe, measured every single day. Because of the extreme speeds and gravitational differences in orbit, astronauts aboard the International Space Station actually age slightly slower than the rest of us on the ground. Forward time travel is a verified scientific reality. Merely moving through different gravitational fields alters your timeline. So, if space-time can be stretched like rubber, what happens if you fold it completely in half? Could you punch a hole straight through to jump backward or forward instantly? This brings us to the Einstein-Rosen bridge, commonly known as a wormhole. It's a theoretical tunnel that bridges two vastly distant points across both space and time, essentially creating a cosmic shortcut. Actually building or using one is incredibly difficult. Without the presence of an undiscovered substance called exotic matter, which possesses negative energy to prop the tunnel open, a wormhole would likely collapse the moment it formed, destroying anything inside. Engineering a stable wormhole might be out of our reach today, but the mathematical architecture that allows for instantaneous time travel is already written into the physics of our universe. The concept of a reality-breaking time slip actually appears far earlier than modern physics. Long before Einstein, the ancient Hindu epic known as the Bhagavata Purana recorded the story of King Kakudmi. Seeking a worthy husband for his daughter, the king leaves Earth and travels to the celestial realm of the creator god, Brahma. Upon arriving, the king finds Brahma listening to a celestial musical performance. Not wanting to interrupt, he waits respectfully. To him, the concert lasts less than an hour. When the music ends, Kakudmi presents his list of suitors. Brahma simply laughs. He tells the king that during that brief concert, 27 Chaturyugas, tens of millions of years, have elapsed back on Earth. The king's reality is devastated. His kingdom, his family line, and the civilization he knew have all been swallowed by the ocean of time. This mythological story acts as an incredibly accurate ancient mirror to the physics of gravitational time dilation. Thousands of years ago, these texts intuited that time was relative, entirely dependent on where you stood in the cosmos. If time bends around black holes and celestial realms, we have to ask how these flexible laws operate on the absolute smallest scale, inside our heads. Nobel Prize-winning physicist Roger Penrose proposes a theory called Orch-OR, which challenges the standard view that the brain is just a biological computer. Penrose and Stuart Hameroff suggest consciousness is generated by quantum computations inside tiny cylindrical structures called microtubules, deep within our neurons. These computations reach into the Planck scale, the absolute smallest resolution of the universe, where the fine-scale geometry of spacetime is determined. When alternative quantum states within these structures superpose and separate, they physically create a bifurcation, a split in space-time geometry. When that split becomes unstable, it collapses, creating a discrete moment of conscious experience. If consciousness truly operates at the quantum level, then the human mind is directly woven into the structure of space-time, potentially exempt from the classical rules of linear time. Through quantum phenomena like entanglement and retrocausality, the brain might access information non-locally across time, a mechanism that echoes the ancient concept of the Akashic records. Einstein's mathematics, King Kakudmi's myth, and Penrose's quantum microtubules all point towards exactly the same truth. The evidence suggests that the now we experience is a persistent illusion. If consciousness is rooted in quantum space-time, we are effectively residing in a non-linear dimension, even if our biological senses tell us otherwise. If you could step outside the flow of the clock, would you choose to travel back to the distant past or venture forward into the unknown future? Let us know in the comments below and stay curious.